Hello, I will talk about basic concepts of differential equations in this tutorial. Uh, we will solve some questions or problems. Problem number one, with example number one, types of differential equations. So the statement of the problem is, what is the type of following differential equations and why? Okay, so this is the first differential equation, dy over dx plus 5y is equal to e power x. So we have to tell that whether it is a ordinary differential equation or partial differential equation. So it is obvious that it is a ordinary differential equation because there is only one independent variable x. So if you see that there is only one independent variable x, and there is also a dependent variable y, which is also 1. Okay, so if we need to determine whether an equation is an ordinary or partial differential equation, we have to look at the number of independent variables. So one variable, it's an ordinary differential equation. This second equation is also an ordinary differential equation because it has only one independent variable x. Although it is different from the first equation in degree terms because it is the second derivative, and of course there is only one dependent variable y over here. So the answer is that it's an ordinary differential equation. Another example of the ordinary differential equation is this. In this case, you can see that there is one independent variable. In this case, this independent variable is t, and there are two dependent variables, x and y. So although there are two dependent variables, so it doesn't matter. It depends, the type of the differential equation depends on the independent variable. If the independent variable is one, that is a ordinary differential equation. Although in this case, this equation is a little bit different as it has two dependent variables, but still it is a ordinary differential equation. So one thing you should note that if you need to determine whether any equation is an ordinary or partial differential equation, you only have to see the terms or the differentials. Okay, all the other terms which have no differential have no consequences, no consequence in this regard. So in this case, if you have considered these three examples, so I would like you to think about it and then try to formalize some rules. So maybe you can answer by yourself to this question. So let's move to the next part. Again, we have to determine what are those types of equations. Okay, so in this case, the equations are presented in different format. So obviously these are represented in a partial differential equation form. In the partial differential equations, you have more than one independent variable. So in this case, there are two independent variables, x and y. The dependent variable is only one, but it doesn't matter. You can have more than one dependent variable, but only thing you have to see is that how many independent variables are there. So if there are two independent variables, then that equation will be called as a partial differential equation. So it is a partial differential equation. Okay, next equation is also a partial differential equations. The reason is not that we are representing it by this sign, which is sometimes called as the dou, but generally speaking, we can also call it as a partial. Okay, so it is not the reason. The reason is that there are more than one independent variable. So in this case, as you can see, x and t are the two independent variables. So it is a partial differential equation. Next is also a partial differential equation. It is different from the previous one is that because it has two independent variables and two dependent variables. Okay, so two dependent variables are u and v, and two independent variables are x and y. Okay, so you considering these examples, you also can think about a kind of rule by which you can identify certain equations to be a ordinary differential equation or a partial differential equation. So in this course, we will be discussing mainly the ordinary differential equations. So this discussion is only for the identification purposes. Okay, but there will be some use of the partial differential equations, partial differentiations later on in this in the solution of the ordinary differential equations, but main discussion will be only related to the ordinary differential equations. Okay, let's now look at another example, which is example 2, differential form of a first order ordinary differential equation. This is kind of like a very trivial kind of question. So what is that question is, what is the alternative form of the following equation? So this is the equation, and you can see that there are some dx and dy terms which are called as the differentials. Okay, so this is another form of the differential equation. So its alternative form, or maybe that form with which we are more familiar, is the one that will contain the terms dy over dx instead of just dy and dx. So if we want to make it into that form, into dy over dx, so what we can do is we can divide throughout this equation by dx. So if you divide this by dx and dx by this, so dx will cancel out from here, and then we will get this equation. Okay, y minus x. Now dx has gone from here, and we get dy over dx. Or you can just rearrange it, and then we can even write it like this. So 4x is here, y is here, and x is here. So this is generally this is like a more like a standard form for writing the an ordinary differential equation, especially in this case, this ordinary differential equation of the degree 1. And for a linear form, I think later on we will also learn that we need to make this coefficient equal to 1. So we will divide by 4x to make it in a more standard form. But anyway, we are not going to do like this. So here we can see that we are just representing that this equation is an alternative to this originally given equation. Then next is this, what is the alternative form of the following equation? So suppose that in this time you have been given the equation in dy over dx form. So sometimes it is useful to convert it into the differential forms. Okay, so that means we need to multiply throughout this equation by dx. Okay, so if you do that, then you will get it like this: x squared plus y squared dx plus 6xy dy is equal to 0. So this you should remember this type of format, and then we will be later on using this type of format in the solution of certain types of equations as well. Yeah, well, it's not very far. Maybe after 1 or 2 lectures, we will be doing the solution of these kinds of equations. Okay, next is this example number 3. normal form of an ordinary differential equation. Well, what do we mean by the normal form of an ordinary differential equation? So suppose we have this equation, 4x is equal to dy over dx plus y is equal to x. Its normal form will be the one where we have dy over dx on one side and everything else will be on the other side. So if we need to convert this into that format, so we need to take y to the other side, so it will be x minus y, and then divide by 4x, so it will be x minus y divided by 4x. And then in this case it will be the normal form of the ordinary differential equation. Sometimes this normal form of the ordinary differential equation is useful in those situations where, for example, if you have dy over dx and all the other terms are here, but the other terms over here should be all in terms of x, okay, and so that in that case then you can integrate it with respect to x. Otherwise it will be a partial integration. So we will also use some partial integration later on as well. So remember that this is the normal form of the ordinary differential equations. This is another example. In this case, this is a second degree, second order equation, y double prime minus y prime plus 6. Remember that I did not actually talk about this. The prime symbol is also for the derivative, so it is a shorthand for dy over dx. So if dy over dx you can represent by y prime as well. So in this case we are taking y prime, and it is implicit that x is a independent variable. Anyway, if you have this equation which is different from the first equation, because the first this equation was for the it was involving the first derivative, but this equation was involving the second derivatives. So what will be its normal form? Its normal form will be the one that will give a highest order of the derivative on one side, and everything else will be on the other side. So if it is y double prime minus y prime plus 6, so y prime should be on the left hand side and everything else should be on the right hand side. So this can be rearranged like this. So you just take y minus y prime plus 6 to the other side of this equation, then it will become y prime minus 6y. So this will be the normal form of the ordinary differential equation when you have the second order differential equation. Remember that I have not talked about the order of the differential equation yet, but I'm going to talk about it in the next example. Order of the differential equation is the one where you have the highest order of the differentiation. So for example, in this case, the differentiation has been done up to the second order. So the order of this equation will be second order. Okay. So in order to completely classify an ordinary or partial differential equation, so we have to consider three things. One is whether the equation is an ordinary differential equation or a partial differential equation. Second is the order of the equation. Okay, first order, second order, third order, or higher order. And the third thing is the linearity, but that we will be discussing in the next example. That is all for this video. I will continue this tutorial in the next video.